Hey guys, I have a new video for you today on circuits and resistors. So I've got two circuits drawn out already, and they both have a resistor and a 10-volt battery, so let's get started. In circuit 1, the ohmic resistor R1 dissipates 5 watts. In circuit 2, the ohmic resistor R2 dissipates 20 watts. Both have a 10-volt battery, and what is the resistance of each of these resistors, assuming that the wires and battery have negligible resistance? Well, using the loop rule, we know that the sum of the change in potentials all around the loop is going to be equal to 0. So, for the first circuit, we're literally just plugging in for the identities for these two things. This is the conventional current times the resistance, and this is the electromotive force. All that is going to be equal to 0 based on the loop rule. Just rearranging a little bit, and then plugging in this for the EMF. So we already know the amount of power dissipated, and we know that power is equal to I times delta V. Delta V has its own identity, which is just I times R. So, a little bit of algebra, the power is equal to I squared times R. Now, we just plug in the values that we know. Since we know that there's 5 watts of power dissipated from the first one, this is I squared. So we're just going to do a little bit of algebra here. Cancel this R squared, cancel that R. And then we have R1 is equal to 100 volts squared over 5 watts, which is equal to 20 ohms. Pretty easy, right? So we're just going to do the same thing for the second one. So we already know from the loop rule that it's going to be the same, because they're pretty much the same circuit, except for a different resistance. So this one has, it dissipates 20 watts of power, and all of this is going to be the same, so we just plug in these values that we get, rearrange it a little bit, and we get 5 ohms. So the one that actually dissipates more power has a lower resistance.